So this is Opto Coupler Sensor. It has 4 legs. The rightmost leg is VCC or input voltage. Then we have ground followed by digital output and analog output. This is light emitter of the sensor, whereas this one is the light receiver. When there is no object between emitter and receiver, sensor will give maximum output voltage or digital high signal. But when the light path is blocked by an opaque object, sensor will give minimum or zero voltage or digital low signal. So now we will connect the wires to the sensor. We will connect the orange wire to the VCC or excitation voltage or input voltage pin, which is the rightmost pin of the sensor. Yellow cable to the ground pin of the sensor, and blue wire to analog output pin, which is the leftmost pin of the sensor. We will not use the digital output pin in this video. In the next step, we will connect the sensor with the NI USB 6009. We will connect the orange wire with plus 5 volt channel of NI USB 6009. Yellow wire to the ground, and blue wire to the analog input 1 channel of the DAC card. Now we will connect the DAC card with the computer system and do the required programming in LabVIEW. Right click in the block diagram, go to Express category followed by Input, and then drag and drop DAC Assistant. In the DAC Assistant settings, go to Acquire Signal, Analog Input, and then select Voltage. Since the analog output of optical sensor is connected with AI1 channel of DAC card, so we will select AI1 and click Finish button. In the next step, we will do the settings of analog input. First of all, we will change terminal configuration from differential to RSC, then we will change the acquisition mode from N samples to continuous samples and click OK button. LabVIEW will ask about adding a while loop to the block diagram. Since we selected continuous sampling, so we will click on Yes button. Then we will go to front panel, and from the graphs category, we will drag and drop waveform chart and do the required settings of the chart, like resizing, unchecking auto scale Y, and changing the range of Y axis. Then we will go back to the block diagram, connect the waveform chart with output of DAC Assistant and run the program. When there is nothing in between the emitter and receiver, sensor will give 0 volt output, but when we put single card in the slot, output changed from 0 to around 2.5 volt. The output of sensor changes when I move the card inside the slot. When I place 10 cards in the slot instead of 1 card, sensor will give 5 volt output instead of 2.5 volt. It means output of the sensor is dependent upon thickness of the target placed in the slot. Thank you very much for watching this video. Goodbye.